Hello, McMath here, ready for another exciting video. Today we're going to be talking about graphing square root functions and graphing cube root functions. Now again, we're dealing with basically the idea of radicals. And you can apply the rules we're going to talk about here for the square root and cube root functions to graph any radical, though for the most part you're not really going to see functions requiring you to graph like the fourth root of x or the fifth root of x and stuff like that. Square root and cube roots, though, will show up. So the square root function will look like this. F of x equals a times the square root of bx minus c plus d. Technically, there could be a number multiplying with the x there. That is a valid function to worry about. For this particular year, though, in our Algebra 2 class, we're not going to focus on the b value. We're going to assume b is 1 and just really deal with f of x equals a square root of x minus c plus d. We're not going to worry about a b value. So the way we graph this, we need 3 points. We technically can use a lot more points. You can technically plot this on your calculator and take a look at the table of values and plot different points, stuff like that. That's all perfectly valid. But if you don't have a calculator, this is how you want to do it. 3 points. We find these points by saying the inside of the radical, the x minus c portion, equal to 0, 1, and 4. Well, why 0, 1, and 4? Those are our first 3 perfect squares. So using those values for x will allow us to have a perfect square root, so then we can actually evaluate and get a nice number without a decimal. You can theoretically plug in any number you want for x. It's just going to give you most likely decimal values that don't work out the greatest. And again, if you don't have a calculator, it can kind of be a pain. Once we have those x values, we can just simply plug them back into the function to find our y coordinates. And there actually is a trick behind finding the y coordinates, which we will discuss as we get through the video. We also need to talk about domain and range for each one of these functions in addition to graphing them. Now, domain is talking about the x values. So you'll find that you're going to typically write domain, which you'll write like this, d, and then our curly bracket, x, such that, straight up and down line, something going on here. So for domain for square roots, since we cannot have the square of a negative number, will generally be x greater than or equal to whatever the first point is when we solve for the 0 value. So if we have, like, for example, the square root of, like, x minus 2, we would say x has to be greater than or equal to 2. That would be what we would consider, again, the domain value there. And let's just put a plus 3 at the end so we actually have a number. Now, in addition to that, we have to talk about the range. So that'd be your capital R then, the curly bracket, y such that. Now, for range, for the most part, again, you're not going to get the square root and get a negative result from that. So you'll find the range for y most times will be greater than or equal to whatever the first y value is. When you plug in, again, this point right here for domain, that first point, if you plug it in, whatever that gives you for y, which in this case, if you plug in 2, you get 2 minus 2 plus 3, square root of 0 plus 3, works out as 3. The only other time the range would be then less than the 3 would be if this was a negative right here. The negative would be implied it's going downwards, in which case you would say y is less than or equal to that first y value of 3. So it all just simply depends where we're going up or down. But the key is to remember that domain range, you need to have a restriction there. You're not going to have generally negative y values unless there's a certain, you're multiplying by a negative, maybe you're subtracting number at the end, and the x values will only be greater than a certain number here. Theoretically, if the b value was negative, you could then have x is less than a certain value, because then it's x is allowed to be negative. But again, since we're talking about b being 1, we're not worrying about that. So for this one right here, we need to graph this and state our domain and range. So again, to graph it, we start off by saying x minus 3 equal to 0, x minus 3 equal to 1, and x minus 3 equal to 4. We set the inside expression equal to the first 3 perfect squares. And when we do that, we get x values of 3, 4, and 7. Well, that's going to tell us when we work out domain, domain will be x such that x is greater than or equal to 3. Because remember, it was always the first x value. It's always greater than or equal to that. Now for the y values, well, we need to plug them back in. So if we plug 3 back in, we'll have 3 minus 3, which is 0. Square root of 0 is 0. 2 times 0 is 0. And then 0 plus 1 is 1. We then plug in the next value, 4. 4 minus 3 is 1. square root of 1 is 1. 1 times 2 is 2. 2 plus 1 is 3. And then for the last one, plug in 7. 7 minus 3 is 4. Square root of 4 is 2. 2 times 2 is 4, plus 1 is 5. So we'll plot those points. X is 3, y is 1. X is 4, y is 3. And then x is 7, y is 5. And our graph will look like this. Notice we're not going to the left of the 3 value, the first x point, because as we said, domain x has to be greater than or equal to 3. And if you notice here, since we're going upwards, that's how we'll know that our range, and you should have these all together when you have a little bit more room on your paper. I don't have a lot of room on this slide right here. But range will be y such that y has to be greater than or equal to 1. That'd be our range. Now, to do this easier, let's take a look at the trick for the y's. Notice, what's our first y value? 1. Where else do we see a 1? Right there. And then look at the rest of the y values. We're going from 1 to 3 and then 3 to 5. We're going up by 2's. Where do I see a 2? Right there. So in the future, we don't necessarily need to plug in the x values. The trick behind this is very simple. The first y value will be whatever we're adding on or subtracting by at the end. So like this, if this was like a -4 at the end instead, we'd start at -4. If there's nothing there, then we would start at 0. And then we increase or decrease by whatever number's in front of the square root. Since it's a positive 2, that's why we're increasing by 2's. Had that been a -2, we would then decrease by 2's. And we can use this to make our lives significantly easier in terms of actually plotting and finding these particular points. That we're not going too crazy with this. So if we take a look at this one right here, we have the square root of x minus 1 plus 3. So we said x minus 1 equal to 0, x minus 1 equal to 1, and x minus 1 equal to 4. When we solve those, we find we'll get 1, 2, and 5. Well, the y-coordinates will start at 3, and then go down by 3's. So it'll be 3, 0, -3. So when we plot those points, 1, 3 will go there, 2, 0 will go there, and then 5, -3 will go here. Now again, we connect them, and there's our graph. We should always be going to the right. We should never be going to the left from that first point for these graphs. If it was like -x minus 1 inside the square root, then that'd be different, but since it's positive x, we have to always go to the right. Well, if we talk about domain would be x such that x has to be greater than or equal to 1. That was our first value. Whereas the range will be y such that y is less than or equal to 3. Because again, the first value is 3, but since we're going down, that's why y has to be less than or equal to 3. So always remember to identify domain range for each one of these graphs. Okay, so that's our square root functions. Now the cube root functions will be in this form. A times the cube root of bx minus c plus d. Where again, this year and this year only, we're only going to be talking about b equals 1. So there will be no number in front of the x. Now, with the cube roots, the shape is going to be in a general form, will look like this. You kind of go up, hit it, and then kind of flatline again. That's how the cube root function is going to look. So we need to make sure our graphs look in that manner. Graphing them is a similar idea. We still need 3 points. What we're going to do to make our lives easier, we find the first 3, or sorry, not really the first 3, we find the middle 3 perfect cubes. Because unlike the square root, you can take the cube root of a negative number. So that's why we're saying the inside equal to -1, 0, and 1. Technically, you can also use -8 and 8 if you wanted to extend it out further to get a better idea of what the general shape looks like. But unnecessary. -1, 0, 1 is all we need, as long as you then draw the shape correctly from there. And then we plug them in to find the y-coordinates, and again, we'll see if there's a special trick we can use so we're not necessarily plugging in there. Now, as far as domain and range goes, well, for each one of these, it's actually all real numbers. If we're doing a cube root, there is no restriction on the x values. You can do cube roots of negatives and positives, so it doesn't matter. And then the range, well, the results of a cube root can be negative, or the results of a cube root can be positive, so there will be no restriction on the range. We can write it like this technically, so d colon x such that x is all real numbers. We can use that notation. So then range Technically, we should make the R for all real numbers look a little different. You can just leave it like that. Or you can just write out all real numbers. That's perfectly acceptable. So over here, we have our 2 cube root of x plus 4 minus 1. So again, we're going to set the inside x plus 4 equal to negative 1, equal to 0, and equal to positive 1. So when we solve that out, we're going to get a negative 5, negative 4, and negative 3. Again, domain, all real numbers, range, all real numbers. Just put that in immediately. Don't forget it. Now, plugging in, we got to make sure we're a little more careful. So we're plugging in negative 5. So negative 5 plus 4 is negative 1. The cube root of negative 1 is negative 1. 2 times negative 1 is negative 2. Minus 1 is negative 3. So far we can't use the same trick, because if you notice, the negative 3 doesn't show up in the problem itself. Alright, well then we plug in negative 4. Negative 4 plus 4 is 0. Cube root of 0 is 0. 2 times 0 is 0. 0 minus 1 is negative 1. Well, okay. If you notice, that's the same as our end value. So the middle now, when we're using the 0 points, that gives us the end point. Alright, so maybe that can help us. And then the final one, negative 3. Well, negative 3 plus 4 is 1. Cube root of 1 is 1. Again, this is why we pick those values. 2 times 1 is 2. Minus 1 is 1. Now, if you notice, each one of these, the y values go from negative 3 to negative 1 to 1. They're increasing by 2, which is this number right here. So we can apply the same kind of trick. We can notice that the middle point now, not the first one, but the middle one, is when we're using the 0 value, that's the end number, negative 1. And then from there we need just to make sure it's in an increasing pattern of 2's. So that's why we start at middle is negative 1, we go to 1 after that, and the one before that had to have been negative 3. Now here's how the graph will look. So negative 5 goes down to negative 3. Negative 4 is at negative 1. Negative 3 is at positive 1. Now, this seems to imply that we are dealing with a linear line here, because those appear to be in us 3 straight lines. And that's what it's going to look like for if you're using these 3 points. Now, I'm just going to show you real quick with the reason why that's not true. I'm not going to set equal the x plus 4 equal to negative 8. I'm going to set equal to positive 8. You don't need to do this in the future. I'm just kind of showing you what's happening. So when we plug in x plus 4 equals 8, we'll get a positive 4 for the x value. And if we plug that back in, or if we use the trick, we'll recognize that 3 would be the y value. Well, that would be this point over here. 1, 2, 3, 4, up 3. So if you notice, we're hitting these points, and then we're kind of going like that. So it's going to be a similar manner than over here. And that's what the general shape is always going to look like. That's why we don't need, in the future, to draw that cube root of 8 points, or the cube root of negative 8 if it could have fit on the graph. Just simply draw the 3 and just kind of make sure you create this general shape we have right here. Okay, that will be the proper cube root shape for the graphs, and you don't need to go too crazy. Future teachers might require you to use the 8 and negative 8 to make your shape. That's fine, there's nothing wrong with that. Just make sure you have a big enough graph then, because depending upon the graph, you might be, like for example, negative 8 would use a negative 12x value. We don't have that on the shape. This graph. Alright, let's do one more. So we have f of x equals negative 3 cube root of x plus 1 plus 2. So we're going to set the x plus 1 equal to negative 1, x plus 1 equal to 0, and x plus 1 equal to positive 1. We're going to find for our x values, we're going to get negative 2, negative 1, and 0. We do know the 0 point is going to use the 2 at the end. The number in front tells us we're decreasing by 3, so that means this has to be a negative 1. This would have had to have been a positive 5 then, to make sure we're decreasing by 3 each time down. So we plot that, negative 2, 5, negative 1, 2, and then 0, negative 1. So we know this is going to be the same general shape. It's going to be kind of something like that. Oops. Okay, hold on. For some reason it decided to end the slideshow. So there we go. There's our graph. Okay, so that's what the cube root function looks like. Generally, like I said, it's very straightforward. Feel free to use your graphing calculator to verify your shape looks correct. That's what I would definitely recommend. But you need to make sure you're showing me by hand how you're finding the x and y coordinate points. Alright, so that's all I got for you today. Again, thank you for tuning in, and I will see you next time.